So today I wanted to talk to you all about some better alternatives to Paramiko. The alternate title for this is going to be Some Excuses to Refactor Your Code, just in case you needed some. So first of all, why are we here? So CLI testing is a large part of what many of us do. Typically we have three main interfaces, that's API, CLI, and UI. Some products, they really only have UI. For those that are kind of web hosted, but a decent amount of us have some combination of the two, and CLI is the one that we'll be targeting today because Paramiko is first and foremost a SSH interaction client. And most of those times we are running those tests against a remote host. So for satellite, we install our satellites, we install our capsules, as well as our content hosts on remote hosts, and then we run our commands there. And it takes a good amount of time to run these types of tests, and we'd like to reduce that amount of time by any kind of means that don't impact the actual results of the tests themselves. And for those of you that have been using Paramiko or currently are using Paramiko, you may have noticed that Paramiko is a little slow and also a memory hog. And maybe you're running things within containers and you like to kind of slim it down so you can parallelize as much as possible. Alternatively, you may be here just because you're looking excuse to refactor your code, you saw a meeting invite and say, hey, that seems interesting, or you just like new things in general. If you're here for any other reason, you can throw it in chat. I do have chat open so I can see what you're saying. Okay, first, let's talk a little bit about Paramiko. It is the default go-to for most Python developers. For the longest time, it's pretty much been the only viable option when it comes to SSH interactions in Python, unless you wanted to do something, really low level yourself, just with pure sockets in Python. Paramiko has been the choice. It is written in pure Python. That's a pro and it's also a con. So the pro is that you can look at Paramiko's source and kind of dig through and understand what's going on with it if you just know Python itself. The con is that since it is pro Python or pure Python, it's a bit slower. It's not really kind of optimized for that case. Another pro is that it does have lots of documentation. It does have a large community because it has been that default go-to choice. And probably more important than all of these other things, it has tons of Stack Overflow answers. So everyone's been asking questions about Paramiko for a very long time. They've almost certainly hit the issues that you're hitting right now, and they probably had 20 people giving them the answer. Some of them not the right answer, but at least Stack Overflow votes up the one that is likely the best answer. And you've probably used it in some form or another. But what are some alternatives? Well, in my opinion, the primary alternative to Paramiko at this point is SSH2 Python. SSH2 Python is a thin wrapper around the libSSH2 library. It is written almost entirely in C Python. So it's a small code base. It is just a thin wrapper around the API of libSSH2. So you're very quickly getting to that C level code. And it also has a lower level API than Paramiko. What I mean by a lower level API is that it doesn't have those kind of higher order functions where it does a number of things at the same time. You kind of have to do a lot of that stuff yourself, but this also gives you a chance to cut out what you actually do or don't need. So some of the additional checks that Paramiko might do, you can skip through that. I recommend you do this by creating, say, something like a session class. And we'll see some examples of that here in a minute, to tailor your SSH2 usage to exactly what you need. But most importantly, it is significantly faster than Paramiko, and we'll see some numbers for that in a minute. It also uses less memory than Paramiko. Unfortunately, this is something that is a little bit harder to determine than just pure running numbers. But since it is written in CPython, it does have less memory usage and a lot of really good built-in automatic garbage collection. Okay, so let's look at some quick examples just so you can kind of see what I mean about that low-level API. So you can ignore kind of like the first few lines. That's just grabbing some information from the keyword args that are passed into this SSH2 session class that's created. This is one of the projects that we use within SATQE. It uses SSH2 Python for all of its SSH interactions. So we create a socket, then we connect the socket. For those of you that have done socket programming, this is all kind of basic. And then finally, we create a SSH2 session, and then we can do a handshake using that session, passing in the socket itself. We could then have two options available for authentication. So we have user password based authentication, and you can also do public key authentication from a public key file. So these are kind of the two main cases for authentication. We don't really need any more for our use case, so we don't have to build any other kind of authentication methods with that. And then here on the left, we have the example of an execute or a run type thing. So we're actually going to be running a command through a session, as well as a kind of helper function over here to read the results and pass them into a results object. So on the run, we just set the timeout to whatever it's going to be. By default, the timeout in SSH2 Python is no timeout. So it'll just run until you kill the program or until the command actually runs. But you can set a custom timeout on the session object itself. You create a channel by opening the session, and then from there, you execute the command on the channel. And then finally, you read in the results from the channel. And reading is similar to what you've likely seen with other libraries as well. You get the size of the read as well as the data itself, iterate over that, decoding it. We decode to UTF-8, and then read all the data in, and then pass that in through a standard out, the status, as well as standard error. Those correspond to just the results that were compiled in that while loop, the channel.getExit status method from SSH2 Python, as well as the channel.read standard error method. Okay, and then you can also do some neat things like this. So this is a method that was actually added recently where we're doing a remote copy from one system to another without actually storing the file on our local system as an intermediate. So this creates two sessions. It's going to be an SFTP up session as well as an SFTP down session. These are all kind of native to SSH2 Python, and you can see that it also, provides some global attributes. So you can just pass in, say, SSH2 sftp. I'll slow it down there. libssh2 fxf-read. Just know that that's what you're going to pass in as the values for the open there. So it's creating both a simultaneous download against one system as well as an upload to another system. We read the data in the download and write it to the upload all at the same time. This way it goes from one system to another without really storing anything in between. Really nice. And as we'll see here in a minute or so, the speed difference between Paramiko and SSH2 Python really comes down to a few different things, but the biggest difference is going to be in these SFTP actions. And this is what I mean by that. Here is a chart. It might be a little bit small for you all, but I can explain it as we go along. So you see a bunch of lines. The higher the line is, the longer it takes for something to run. We see on the line that there's two big purple and blue lines going all the way up to the top. That's the amount of time it takes Paramiko to do an sftp read, as well as the cumulative total for all of the other actions that are going on in here. So each of the clients is doing an auth, a channel open, a channel read, getting the close and exit status, doing an execute, an sftp read, and then closing out. Overall, you can see that it took Paramiko 10 minutes to complete all this, whereas with SSH2 Python, it took 59 seconds. So quite a considerable performance boost if you are doing SFTP actions. Without SFTP, we still have a considerable boost. For example, it took Paramiko a total of 32 seconds for all the auth actions, whereas it took SSH2 Python 18 seconds. It took Paramiko 669 milliseconds to do the execute, whereas it took SSH2 Python 94 milliseconds. For a direct comparison of the numbers, here's another handy chart that shows you how much faster SSH2 Python is than Paramiko. For auth, it is 1.71 times faster. For channel opens, it's an average of 8.85. For channel read, it is 2.68 times faster. Close and exit status is 4 times, execute is 8 times, and the biggest difference between the two is when it comes to SFTP actions, which it is 17.12 times faster. So averaging all those out, it is 10 times faster than Paramiko. If this isn't kind of incentive enough, I don't know what else to tell you guys. When it comes to learning the two, it's not that big of a deal, but the sheer performance gains that you'll get with SSH2 Python is kind of hard to argue with. I think the biggest downside is it's harder to say SSH2 Python than Paramiko. But that's just my opinion. Any questions before we move on? And you can type your questions in chat as well. Currently, which team is using SSH2 Python? I'm not sure which each team is using in general. I'm gonna guess that most are probably using Paramiko since it has been the default. Our team is currently using a mix of Paramiko and SSH2 Python, but conveniently, I may be in a position to move us off of Paramiko altogether, which is something that I'm currently doing. So we're currently using a mix of Paramiko and SSH2 Python. All of our host interactions from the future, well, from kind of a couple months ago on, are moving in that direction as well. Yeah, Guillermo, a lot of teams use Paramiko. I think we should change that. It may take a little bit of a rewrite, but once you get that down, it's not too bad. Okay, so you may be asking yourself this question: what if I wanted to do a major refactor? Well, if you're that brave, you might as well go asynchronous. Something that said downtime is required if any team wanted to move their code from Paramiko to SSH. It depends on what your refactor looks like. You can do it so that way it's effectively just a single pull request, depending on how your code is laid out. Like if it's just as simple as switching the runner, then it could be really quick. Otherwise, if everything kind of is almost directly using Paramiko and not through some type of abstraction, then it could take longer. Now we got about 10 minutes left, so I'm going to try to get through the rest of this. What if I wanted to do a major refactor? Yeah, go asynchronous. You can run multiple commands against a single target, or you can run one or multiple commands against multiple targets. You can greatly speed up the overall execution time, and it also removes the need for threading and multiprocessing, as well as all the kind of headaches that go along with this, like trying to coordinate resources between the two. So with async, everything technically runs in the same thread. It just is cooperatively concurrent. Now, this does require that you run things on Python 3.5 plus, as this is where the kind of the good support for async came in. and async can be a little bit challenging. But from what I've seen from brief looks at something like PyTest async.io, it actually doesn't look that hard to make async tests. It effectively introduces a mark, and there may be a little bit more into it than that, but I've only had a little bit of time to look at it, as we're not currently considering moving our framework to asynchronous. But you definitely want to set up some type of semaphore when you're running tests asynchronously. Otherwise, it's an easy way to stress test your product. And what I mean by stress test is, depending on the amount of tests, stress test it to the point where it will break, which may be what you're after. Okay, so here is a quick chart that I did. Ran through a number of kind of scenarios with different numbers of concurrent workers. Well, each test ran 765 commands against a single host. Initially, it took about 30 minutes. We can quickly see that as we increased the amount of concurrent workers available, even getting down to around 5 concurrent workers, that brought that down to about 6 minutes. And our peak time throughout this seemed to be around 10 concurrent workers, where we hit around 5.5 minutes. So about 30 some minutes down to 5.5 minutes is a pretty big boost in performance. Though if you look closely at the chart, you may see a slight increase on the line there. That's because you do have to have a balance between, just the right amount of workers and too many workers, where it's putting an extra strain on your system. So if you're sending, say, 100 concurrent requests at your product and it has to process all of those, then that might slow down the overall time it takes to process that command. Another really good thing about doing things async is that if one action takes significantly longer than the others, and you have, say, 4 or 9 additional workers to process other commands, then they could be doing the quicker things while the slower thing is still running. Okay, so now we're at the questions slide. Let me look at the questions that are in chat. If you have any more questions, you can definitely add them to the chat as well as ask them in person. Waldemar asked, OpenStack's testing suite and framework Tempest is using Paramiko. Did you hear or have a look at that already? It may be hard to replace. The Tempest is quite big and most likely relies on many Paramiko abilities. I'm not familiar with what each team is using for their testing framework. Almost certainly everyone has their own kind of implementation of that. And if they are Python based, there's a good chance that they are Paramiko based as well. But it kind of really depends on how they set up that that framework in general. So if they have a command type class or some type of SSH helper function that runs commands, it may be easier to switch it on the back end instead of having, worst case scenario, each class is calling or each test is calling Paramiko methods. That would be kind of the worst case scenario when it comes to that. Ideally, people should be setting up some type of either intermediary through a class or maybe some helper methods, worst case. Tempest. I'll actually open up Tempest in another tab and definitely take a look at that. I'm sure over the next few hours of meetings, I might be tempted by Tempest to look away.
Jake, difficult has it been to implement some of the Paramiko convenience and helper methods that Repetella, for example, as a framework is using? So that experience of replacing Paramiko, obviously most of the users of Paramiko are going to be using its helper functions, its convenience methods, and have a pattern there that they're using those methods. So has it been difficult to implement any of those yet? Have you found SSH2 has most of what people are looking for, maybe just with a different API, or has it been kind of difficult?
Yeah, the largest difference has been the API between the two, but for the most part, we're not actually doing anything kind of crazy with Paramiko that I've seen so far. Let's caveat that Robotel is a large code base. I haven't seen anything that is outside of the bounds of Paramiko's API for what SSH2 Python commit implements. SSH2 Python does a low-level wrap around the entire libssh2 C API. It should be one-to-one, at least on the low level. If you want to create helper functions like we saw some examples earlier in the demonstration, then you can absolutely do that. So these are all helper methods that were created so to make it much easier to actually work with these kinds of things. So you can just call a session class, passing in a host, a username, password, and then immediately start executing commands over it after you connect. Okay, I think we have about 2 minutes left. So if you have any final questions, go ahead and throw them in the chat or just call them out.